Hello everyone, and a very, very warm welcome. I hope you could hear me well. If all is good with the sound, please put plus to the chat so we know that you could hear us and the presentation works well. Would really appreciate because my heart is pounding and I'm worried if all is okay. Thank you. Okay, amazing. So first of all, thank you so much for joining us today. My name is Diana and I will be the host for the session today. I'm truly excited to be here together with my wonderful colleagues, Vitaly and Serhiy. We'll give it just another minute or two to let all of the participants in. In the meantime, let me briefly introduce myself. I've been working in business development for over 5 years, helping small and mid-sized businesses to grow and succeed. Particularly, the last place was the head of sales. But today, all of the spotlight is on our technical experts, and I can't wait for you to hear them. But before we begin, just a very quick note. If you have any questions during the session, feel free to drop them to the chat. We will have a Q&A session at the end, so we will be able to address all of the questions. Feel free to drop them to the chat. So just one more minute or two, and we will be ready to begin. In the meantime, maybe while everybody is connecting, let me briefly introduce our speakers for you to have the information a bit more. So we have Serhiy. Serhiy is our SDO director. He has over 13 years of experience in software development and architecture, particularly working in different domains, technologies, and of course, he has a strong passion for the .NET ecosystem, Microsoft ecosystem, particularly .NET. He has led and contributed to numerous projects involving .NET, computer computing, Blazor, MAUI, and AI. And he's really passionate about building modern scalable systems to help grow the tech. That's why we're here to talk about the legacy migration today, because this is a very important topic and a hot topic, I would say, for many businesses. The second speaker today is Vitaly. He's our solution architect, and he specialized in designing scalable high-performance systems. His work focusing on using modern technologies like .NET, AI, cloud-native services to create software solutions that truly match to your business needs and, of course, fulfill all of your wishes, because this is also very important not to have the workable solution, but something that really meets to your business objectives and what you want to have in the end. He also plays an active role in our LeoBeats R&D initiatives. To be honest, he drives internal excellence on a lot of AI projects. And if there is something that you would like to discuss later on, we will be happy to answer your questions during the Q&A session. In the meantime, I hope everybody has joined, and it would be good to start, because to be honest, we have a lot of things to discuss. So I will be happy to handle the word to Serhiy. And just to recall, if you have any questions, feel free to drop them to the chat. Serhiy, please, the stage is yours.
Thanks, Diana. And hello, everyone. Thanks for joining us. Today, we will talk about legacy system modernization. We will look at signs that could show and what you should consider or partially all or even full modernization of your application. After that, we will explore benefits and approaches, how to deal with that. We will base a lot of stuff on our experience, and Vitaly will provide more examples of that in the next slides. And after that, we will evaluate the risks of ignoring these signs and probably the proper time for modernization and some consequences that it could have. So let's jump into signs that could indicate for you that your application of software system could need modernization, and we split it and combined it to major categories. And on the next slides, we will go one by one to give you more clear understanding and signs what it could show or give it some clues to you as a customers or business owners or technical decision makers on your software actually. So first of all, of course, this is security and compliance risks. We will start from the security, and software vulnerabilities actually discovered daily, if not hourly. This is crucial theme as of now, and I believe forever. And we are really responsible for our software and responsible for quick fixes that are crucial to manage them, to provide them, to plan them, or just to deal with them without just dropping them to technical debt and just keep them alive for a long time or forever. And actually, a lot of attacks, cross-site scriptings, or any kind of injections, or even legacy or outdated authentication and authorization mechanisms is really crucial nowadays, and systems should evolve in parallel with all these threats that actually discovered, and this is really should be managed by your as a software company owner or business owner, and immediately take care of that, because this has a lot of risk that which we'll recover later, and I will show you some impacts that it could have in some groups, how they could be categorized for their right prioritization. And the second part of this sign is, of course, the compliances. There are a lot of them. Here we mentioned only most popular or most famous ones like HIPAA, GDPR, ISO certification, or even PCI DSS. And this actually the fundamental thing that just build the trust to your product, to your company, or any kind of services that you provide. And legacy software usually lacks some parts that could give you the easy access or easy ability how to introduce this or how to evolve all this stuff with your products. And of course, think about the competitors that could provide some compliance uh, compliance compatible software. You should keep this in mind. And if you just face in any kind of your development journey or maintenance of your product with the lack of any kind of this stuff, this really a huge and red flag sign that maybe not all your part, not all your software need modernization and updates, but maybe some crucial or partial updates for modernizing your system could help you just evolve your system and compliances to the next level. This is really important, and without that, in the long term, businesses could even fail or just lost the trust from their customers, and the customers for business the most important thing ever. If we're going forward, let's talk about compatibility integration. We just talked about the painful compliances and some regulatory updates that could just pop up any time in the future, or even just now while you're on our presentation. And you should be aware of that, and parts of your system should be ready for that. And almost every application, it's not like standalone application without any integration. And usual application has a lot of them on backend, on front end, or any kind of platform um, or place or cloud where your software is actually running and working. And the hardest thing just actually to maintain this integration. And if you in some um, in any time you see that integration with the existing platforms, you could integrate with the tools, with your external business partner, or even internal system, if this is a big project. If you faced with some issues or some huge workarounds or some manual work for doing them, this is the first sign that your integration is not easy to do, and you need to keep them alive and updated your existing integration. And moreover, you need, or you may want to add some integrations on top of that, and this should be easy for your system. If this is not easy, and if this is not could be included in your next release without any high tensions, this could be the sign of that parts of your system need modernization as well. And this workarounds and this instead of compatibility adaptation, this is really good sign, because a lot of things could be just done quickly with some manual work, or some developer on your backend could make some workaround and just put a new item to backlog or technical debt to proceed with this feature. Here I recommend to, on the regular basis, analyze and work with your backlog and technical debt to figure out what could be done, what could be part of your next scope, and just deal with that, because this workaround just will take a mess in the future. And it's really a really good sign that you need to cover them to be able to integrate existing and new integration parts of your application. The next things is I think relating to changing business needs, that actually this is the sign that there are some inability to meet some changes that business wants or your customer wants, and we are living in very dynamic time, and your software should be flexible. In ideal case, it should be flexible to adapt to the customer demand, to the business demand, or any kind of stuff. If you struggle with something, this of course is a problem for that, and this should be quickly addressed and responded to market change or your audience changed. You have to plan this quickly. If you struggle with this is also a clear sign that something should be done in terms of modernization to be more flexible. And all these challenges that will pop up for you during new products, launching of new products, or even updating existing services, if you're faced with the challenges, this is also the sign that your system may be not flexible as you would expect. And in long term, this could really lost to any kind of competitors or other software companies, and this also goes to lost business opportunities, and this is the worst thing ever that could happen. So flexible system is really important for that. The next things, this question about how fast we can is our time to market, and if we measure these metrics in any kind of tools or just manually, if your time decreases, this is a clear sign that your system becomes more robust, more hard to maintain or even deal with. And if you see that you just have some inability to quick launch of new features, um, or some business needs, or your minor change that you plan to the next sprint or to your next release just trigger the huge retesting, A/B retesting, integration testing, or whatever. This is the clear sign that something goes wrong, because minor change should have the scope, and this scope could be tested very fast. And you should be fast here, because your competitor could be faster than you, and this is not as good for software development to keep your customers and your audience not only on static level, but also grow it for the future. And of course, addition to that, long development cycles and releasing of new version should be fast and ideally granular. If it's not about your system or your software, this is again the sign for that some modernization needed for the whole application or the parts of them. The next thing is this performance. This is also the hot theme and clear signs here. This is slow response times. You measure this by feedbacks from your customers. They could complain about slow responses, freezing time, crashing, and other timeouts because of I want to buy something or I want to get some service. And this is really problem that could be problem for the future. And to deal with that, I really advise not just monitor this on the regular basis, but also under some peak loads or enabling to cover a lot of concurrent transaction or request on something else, like for example, for Black Friday. If this is happens sometimes, this is also a problem, not just take this down and just we work all year okay, but Black Friday is total mess and we just sell nothing. This is not an option. So we should take care of the consistent good performance and the performance in the peak or high loads also. This is very important to that. Maintenance difficulties, this another topics, and really maintenance, this is what application need all the time in the almost every cycle of existing releases or future releases, and fixing bugs, act features, and any kind of troubleshoot should be easy or just doable in the good amount of time to maintain your application. If you struggle with that or your development team struggle with that, this is really a good sign that your system should be modernized. And usually even modernization of even a part of your system could solve a lot of problems. And the last but not least, we should also remember that lack of development expertise is also a big threat, and a lot of skills developers, they are want to work with the latest technologies, and as your software evolves through the time, if it's just have a less modernization phases, in the future, you could see that you are really struggling to fill the developer's role, or you could see the sign that you actually overpaying developers in your headquarters because of inability to replace them. And after some modernization of your system, this amount of developer that you could offer a work or just involve them in your team could drastically increase, and this will be not a blocker for you. Yeah, that's it for the first part. And here I will pass the word to Vitaly. Vitaly will go a bit dive deep to our examples and our real cases. So Vitaly, please proceed. Over to you.
Thank you, Sergey. Hello, everyone. Yeah, so within the next block, we'll explore the benefits of modernizing legacy systems, discuss how to effectively assess your current system, outline the various modernization strategies you can employ, and then dive into some real-world case studies to see these principles in action. So let's begin by looking at the key benefits of legacy software modernization. Uh, it's So modernization isn't just about acquiring the newest shiny technology, it's fundamentally about how these updates deliver real practical benefits to your business. First and foremost, there is increased security and compliance. So legacy systems often harbor unpatched vulnerabilities, and modernizing allows us to implement forward-facing security best practices, sometimes even before regulations explicitly demand them. And this proactive approach protects your organization from data breaches, penalties, legal liabilities, and potential reputational damage. Think of robust security as the core outcome. Next is improved efficiency and performance. Upgrading software significantly enhances operational efficiency. It makes scaling and managing workloads much easier. Modernization also opened the doors for cloud migration, load balancer, advanced caching system, and containerization tools like Docker and Kubernetes, all of which boost your system scalability and performance, leading to a significant productivity boost. Also, a major driver is cost saving. Modernizing legacy software help reduce operational expenses. IBM highlights that successful modernization could lead to a 14% increase in annual revenue and from 30 to 50% reduction in application maintenance and operational costs. So these are lower maintenance costs that directly impact your bottom line. Modernization also enables better integration with modern technology and enhanced compatibility. By adopting modern architectural approaches, your system can more easily integrate with advanced technologies like generative AI, ML-based automation, and this ensures that you can leverage a modern tech stack, staying on top of the software development trends, and maintain your competitive edge. And crucially, it leads to an enhanced customer experience and improved user satisfaction. Legacy applications often feature outdated with complex user interface that can frustrate users. So modernization improves usability, functionality, and overall look and feel of your application. This not only helps attract new customers, but also increase loyalty and satisfaction among your existing user base, ensuring your business remains relevant. In a sense, modernization is a strategic move to future-proof your business, making it more agile, secure, and efficient. Before embarking on any modernization journey, a thorough assessment of legacy application system is paramount. This step is crucial for ensuring a successful modernization and smooth transition. At Leobit, we utilize a comprehensive legacy system assessment framework, and this involves several key steps to deeply understand the software capabilities, limitations, and potential areas for improvement. We begin with technology analysis. This foundational step involves a thorough examination of the software programming languages, frameworks, databases, and other tools. So we aim to understand the relevance or obsolescence of the current tech stack, identify technical debt and unsupported technologies, and determine if the current stack can handle upcoming changes. Based on this, we can suggest modern alternatives, often presenting detailed comparison tables of technologies to aid in decision-making for better performance, security, and maintainability. Next is the architecture audit. Here we go beyond examining basic structure to understand also non-functional qualities for future success. This typically involves quality attribute workshops where we facilitate collaborative workshops to identify and set priorities to key system attributes like scalability, security, maintainability, or performance. Also gathering of architectural requirements and modernization roadmap creation. So based on these attributes, we define architecturally significant driving requirements and create step-by-step plan outlining necessary improvements. This holistic view helps determine if the current architecture can support future enhancements, scale with business growth, and identifies existing flaws or bottlenecks. Then we conduct an infrastructure assessment. Here we review the hardware and software environment, including servers, databases, network, cloud services, to determine if the current infrastructure supports the modernization goals. This process highlights inefficiencies, also assess the feasibility of cloud migration, and ensures that the infrastructure can handle failures and maintain business continuity. A code review is essential. Without proper care, the often extensive code in legacy system can become problematic over time. So we examine the source code to identify bugs, code smells, and areas where improvements in readability and maintainability are needed. We evaluate how easily the code can be understood, modified, and extended, and pinpoint areas for efficiency gains. Also, a security audit is vital. Protecting sensitive data and ensuring compliance are not negotiable. Holding various ISO certifications, we have proven experience in building GDPR, HIPAA, and OWASP compliance software. After auditing, we provide clear recommendation to safeguard your system and data both during and after modernization process. We also perform UX UI review. Legacy software often features our outdated design, making the system confusing, especially as new features are added. Accessibility for users with disabilities can also be a significant concern. Our UI UX experts evaluate the look, feel, and the overall user journey, providing recommendations to ensure the software is user-friendly and accessible to everyone. And finally, performance testing. This involves testing the software under various conditions, such as load testing, so simulating high volumes of users or data, and stress testing, assessing performance under extreme conditions. The results help us understand how the system will perform as usage scales and identify any bottlenecks that needed addressing. So this comprehensive assessment helps us highlight critical issues like time to market delays, high maintenance costs, expense scaling, and security vulnerabilities. Understanding these pain points allow us to choose the right modernization strategy tailored to specific business goals. And also let me illustrate with an example from one of our projects. So a client approached us with the goal of modernizing their SaaS product. Their key drivers were a desire to migrate to the cloud, optimize operational costs, and importantly, transition from a single tenant architecture where they manage different environments for each client to a multi-tenant solution. This would allow them to serve all clients within one scalable application. And of course, they aim to update the user interface to increase user satisfaction and become compliant with accessibility requirements like VGC AG 2.2, modern requirements for accessibility. So we began by thoroughly assessing their current solution following the steps I just described, and this process allowed us to develop a detailed modernization roadmap. We identified numerous pain points and weaknesses, reviewed third-party dependencies, and gained a clear understanding of the system's considerable size and complexity. Once we have a clear understanding of the legacy system, we can explore different approaches to modernization. Gartner recommends 7 essential strategies, often called 7 Rs, which are categorized based on their ease of implementation and their impact on the system and business process. Generally, the easier the implementation, the lower the risk and impact, and vice versa. Based on our experience, it's almost always a hybrid approach. This means that after the assessment, we can often break down the legacy system into smaller, manageable pieces and apply different strategies to different models depending on their specific needs and characteristics. So let's take a look at each strategy. So retain. This is essentially a wait-and-see approach. It's suitable if your software was recently modernized or if the return of the investments for an immediate upgrade doesn't justify the effort. In this scenario, you monitor the industry and aim to keep the pace. However, persisting with this approach for too long can lead to the system failing significantly behind. For the client case that I mentioned, this wasn't suitable as their system was already quite old and clearly required updates. Even a retained strategy needs a proper monitoring and cost analysis to ensure you take the right actions at the right time. Rehosting, also known as lift and shift, this involves migrating the legacy system to a different environment, like a cloud, as is, without minimal or no code changes. It can improve availability and performance by leveraging cloud resources, but it doesn't typically address underlying application issues like security flows or outdated functionality. Rehosting was a necessary component for our clients' modernization as we needed to migrate their resources to Azure. However, due to the project size and complexity, rehosting alone wasn't enough, but it can be a viable standalone strategy for smaller projects. For example, replacing on-premises ES hosting with Docker images hosted in the cloud. And this can offer benefits such as improved scalability, potentially lower infrastructure management overhead, and better disaster recovery options. And we successfully implemented this for other clients, and I will touch on those examples a bit later. Replatforming, this goes a step beyond rehosting. It involves also making moderate changes to the legacy application code configurations or data to ensure a smooth migration to different cloud platform or infrastructure. This approach can bring quick performance improvements and enhance scalability. It's particularly useful for applications currently hosted on premises or when their existing cloud platform isn't meeting demands. Replatforming was also part of our clients' modernization because their aim was not only to migrate to the cloud, but also to leverage managed services from the cloud provider, so Azure in their case. For instance, migrating an application from a virtual machine to Azure App Service or moving a database hosted on premises using Microsoft SQL Server to Azure SQL. And this gives us benefits like reduced administrative burden, built-in scalability and reliability features provided by the cloud platform, and often optimized cost for those managed services. Refactoring, this strategy focuses on restructuring and optimizing existing code without changing its external behavior. It offers quick wins by reducing technical debt and improving non-functional attributes such as performance and maintainability, and is a good approach for improving software quality and stability, but requires extensive testing, as refactoring can introduce new bugs. Regular code reviews and refactoring sessions are good practice for any project to stay on top of the technical debt. In our client case, this strategy was suitable for small, isolated service that still perform well, but requires updates to be compatible with modern libraries. For example, we took the existing code base of an email sending service, refactored it, enhanced its security and observability, and integrated it with a modern email sending provider like SendGrid. Re-architecting. This involves a comprehensive redesign of the code to shift it to a new application architecture, such as microservices, serverless, or event-driven, to align with modern standards and leverage improved capabilities. It's ideal when you need to transform functionality or user experience, especially if the underlying technology is modern, but the application design is outdated. We use this strategy in many parts of our client's system. One key example, as I mentioned, was the switch from a single tenant approach where the client has completely separate environments for each of their clients to a multi-tenant architecture. While we ensured data remained isolated, so one tenant couldn't access another's data. The code base and the application infrastructure became shared, simplified management and scaling. We also re-architected the authentication mechanism, which I'll elaborate on shortly. Rebuilding. This means redesigning of or redeveloping a component or application from scratch while preserving its original scope and specifications. It's often an incremental modernization, taking one functional block at a time, rebuilding it, using it new technology, and deploy it as a distinct service or application. You can encapsulate all data and functions and make them available via API. This is generally a lower risk approach that allows for concurrent development of new features. And rebuilding was our main strategy for the overall modernization project. So the client core application was built as a monolith using web forms, and we are migrating it to the client server architecture with modular monolith at the backend, adopting a vertical slice architecture, all while maintaining existing functionality and developing new features. And the last one, replacing. So when your legacy application no longer meets current business needs, you might need to replace it entirely with new software. While this is often a fresh start, it possesses significant challenges with potential disruption during the transition. This option is suitable for applications that are no longer relevant, useful, or viable and cannot be effectively modernized by other means. It implies radical changes and needs careful evaluation, planning, and management. In our approach, we effectively replaced models one by one. Users could still work with the single application interface using older, not yet migrated models alongside newly modernized ones, until all old models were eventually replaced and the original application could be deprecated. I'll share more details on how we manage this on the next slide. So choosing the right strategy or combination of strategies depends heavily on the findings from the assessment phase. and the specific business goals and constraints. Now, let me show you the results of our assessment and our strategies were discussed, translated into modernization approach for our client. So we started with a monolithic web forms application. This application was directly connected to its database. All business logic, UI rendering, and data access were tightly coupled within this modeling and its common characteristic of older web forms application. And this architecture made changes difficult, time-consuming, and inherently risky. And as you can see in the early migration part of the diagram, the first crucial step was to introduce a Strangler facade. This facade sits in front of both the existing web forms application and the new front-end application. Its primary job is to intercept incoming requests and intelligently decide whether to route them to the old legacy system or to the new modernized components. This enables an incremental module-by-module migration rather than attempting to rewrite the entire system in one go. A big bang approach that's often dangerous, so we adopted a phased strategy. We identified distinct models within the web forms application and then created and analyzed a modules dependency graph to determine the optimal order of the migration, often tackling less dependent or more critical modules first. We developed a new ASP.NET Web API backend application adopting vertical slice architecture and a corresponding modern frontend app, in this case using Blazor. A critical consideration during this phase was data migration. One option was to continue using the same databases, however, this risked inheriting problems from the old application, such as outdated schema design, potential data integrity issues, or performance bottlenecks embedded in the existing database structure. A thorough data analysis as a part of the assessment is crucial to understand if existing data stores can be used without significant drawbacks. Alternatively, as displayed on the diagram, we could introduce new database. This approach avoids inheriting legacy problems, but introduces significant complexity with data synchronization between the old and new databases. There will likely be cases where a single data entity is shared between models and can be updated simultaneously from both the old and the new application. And to tackle this, we used an updates queue and a synchronization job to maintain data consistency. However, this can introduce latency, meaning user might not see updated values instantly. So sharing entities that require real-time consistency should be minimized as much as possible. Also, I want to highlight a few key challenges that we addressed. So the first one, shared authentication. We had to devise a strategy where both the old forms application and the new application could share authentications seamlessly. This means user should log in only once and have access to both applications. Our solution involves developing a centralized identity provider and implementing token-based authentication that both systems could understand and trust. Another point is iframe integration. In some cases, to provide a smoother user experience during the transition, we used iframe integration embedding old web forms modules within the new Blazor application. And this requires careful handling of security protocols and inter-frame communication. Also, the Strangler facade pattern effectively managed complex redirections to ensure users were seamlessly navigating between the old and new parts of the system without confusion. Also, more cross-cutting concerns, so we had to establish a consistent approach for handling cross-cutting concerns like logging, error handling, security across both the legacy and new components. And we did a thorough check of existing libraries and package compatibilities with new .NET stack. It was essential for us to avoid unexpected issues and delays. And as shown in the later migration section of the diagram, we continued this iterative process. More and more web forms modules were migrated to the modern ASP.NET Web API and Blazor and you can see that the size of the legacy application rectangle gets smaller, while the modern front-end and modern backend application rectangles grow, visually presenting the migration of more modules. The Strangler facade was reconfigured with each model migration to route an increasing number of requests to the new models and progressively fewer to the old web form system. And the legacy system was gradually strangled, shrinking in terms of its active responsiveness. An important lesson learned was to keep things as simple as possible and avoid overcomplication. It was very easy to get carried away with new technologies, but focusing on delivering value incrementally and maintaining a clean architecture for each new model was key to success. We also recognize that the migration process itself is an opportunity to develop new features, update always, and enhance compliance accessibility. So we didn't just do a lift and shift of features. Where appropriate, we actively improved them. And finally, as depicted in Migration Complete, the modern front-end app exclusively calls backend application, and the legacy web form application is fully retired and decommissioned. This incremental approach using Strangler facade allowed us to manage risk effectively, deliver value continuously to the client, and gradually modernize a complex system without resorting to a high-risk all-or-nothing rewrite. It also provided invaluable opportunities for development team to learn and adapt throughout the process. On this slide, you can find links to more case studies from projects we have delivered. Links to them are embedded in the presentation, which we will share with you after the webinar, so you can explore them in more detail at your convenience. I'd like to briefly highlight a couple. The real estate investment management platform. This case involved a mix of strategies, including rehosting and significant re-architecting with complex data synchronization challenges as we migrated them to the cloud. And the legal case management platform, this was another complex project involving rebuilding, replatforming, and re-architecting a legacy application that handled critical operations in the government and legal sectors. Maintaining uninterrupted functionality throughout the migration was paramount for us to ensure the continuity of this vital operation. That's it from my side. Sergey, passing the word to you.
Thank you, Vitaly. Give me a second to just reshare my screen. So now should be ready. Yeah, okay.
All good.
Yeah.
Okay. Again, thanks, Vitaly, for just explaining and showing us these cases. I will proceed with the last part of our presentation. And as I mentioned, we also need to emphasize the risk of not modernizing and ignoring all the stuff or just putting it to tech debt or backlog. And it's really convenient and really useful to separate these risks to three main categories. First of them is business impact, and of course, this separation related to the impact that which they can proceed. It could be just more granular, split it to financial or strategic impact, which also part of tech solution impact, and of course development impact, because development is the core part of any software solution development overall. And if we have a look for these three categories, there are a few items in each of them. I will go through all of them very quickly because we will have the Q&A session, of course, at the end. And as we saw earlier, the regulatory non-compliance, this is really again about the failing to meet the mandatory legal or industry or usually some government rules and standards. And this is the crucial risk to even lose customers or their trust. Negative user experience, usually this is the risk about your users became just frustrating or they just difficult to navigate, use your system, or it generally maybe unpleasant to interact with your system and make those tasks that the system aims to do. High operational cost, there's also the business impact because the cost management is one of the vital thing nowadays, and the system on a day-to-day basis could be extremely expensive, and in total, this will have the huge impact to the whole business. Inability to meet market demand or agility, this is again about flexibility that we saw before, and it's really important to quickly adapt. And if not, again, we have competitors, we have other software companies that could be more flexible that we, and we should take care of that for sure. Security vulnerabilities, this is the top theme again, and this is any kind of weaknesses within the system could be exploited by anyone, and this could be losing or data of your customer or any other kind of stuff. And this data breach on or any authorized access could be potentially just ruin the business, and this is really important. And on top of that, of course, this is the worst thing ever for the business. This is reputational damage, which we, of course, can't allow, we can't afford. Regarding tech solution impact, we again step back to poor performance and scalability. And nowadays, systems should be scalable because we just focus on growing our system, growing our audience, our users, and they should be happy. With performance and scalability on the regular basis or even during the peak loads or some peak concurrency events, let's say in that case. Maintenance difficulties. This is again, all software need to have some update, fixing bugs or any kind of maintain. And if this becomes complex, this complexity only grows with the time. Obsolete technology stack. This is again outdated technologies, and if they are no longer supported or even have again the lack of security or any backdoors or any exploits, this is the risk for business and should be taken care of. And inability to integrate with modern system, this is again integration issue, and a lot of modern and very high load or very nasty services are really pop up and implement every day. So inability to integrate with them just block our software and block our business, even if we find the cool and fancy solution which we want to integrate to improve our system. And the last one, development impact. If this really continues, this first of all is this lack of development expertise, which will grow up with the time because technologies again became obsolete. And in the long term, this also decrease employee productivity. Your team will be less productive, and this again will have impact for all this chain, for your future releases, for your time to market. And this chain could be very long, and a lot of items will be impacted by this productivity and really just block your business and your software to evolve. This is the main risks that we that I want actually to emphasize here.